Hello everyone, welcome to lecture 4 of our week 8 for our course Metrics and Analytics of Marketing. As all of you know that in this week we had been discussing about various metrics associated with pricing strategy. We discussed about reservation price, we discussed about price premium, we discussed about linear demand curve, we discussed about price elasticity. Now in this lecture we will try to amalgamate all this concept in order to come up with the optimal price, that is the price point where the profit for the organization is going to be maximized. What we will look into is that, as we have seen that we can get different reservation price for different individuals or different segments. In one of our examples that we have seen that if we consider that entire market consists of 11 individuals, there were individuals for whom the reservation price was just $30, there were individuals for whom the reservation price was $40 and so on, and then it reached up to $130 and ultimately we set the price at $100 as per that example is concerned. So, what happens? If we are setting the price at $100, we are losing some opportunity for those people who are actually ready to pay $130, $120 or $110, and that is an opportunity that is lost by the organization, which in turn from the other side it is a consumer surplus for the consumers, right. So, now in this context, how companies should look into it, how companies should try to leverage on this consumer surplus or lost opportunity. There are multiple ways. I mean, let us say you can price the same product differently in different segment, probably with a bit of value addition, which does not impact much about your variable cost. This is another way of optimizing your profit for the organization. Or sometimes you have to keep the price of the product constant throughout all the segments and then try to fix up the exact price so that your value is optimized. So, let us dive more into this concept of optimal price and gross margin at the optimal price. Optimal price is nothing but a specific price point where the gross margin is at the highest level. Let us look into these two metrics one by one. Optimal price, the optimal price is the most profitable price for any product. Optimal price is the price that will generate the greatest contribution by a product after deducting its variable cost, that is the most profitable price for the product. So, basically what we are trying to calculate is that for each price point we are calculating the contribution margin, then multiplied by the demand at that particular price point, and whichever price point is giving this highest amalgamated contribution, that will be my optimal price point. So, basically we are just doing a optimization of a function which can be represented as price minus variable cost multiplied by quantity demanded at that particular price point. So, this is what is covered under optimal price. In a linear demand function, the optimal price is halfway between the maximum reservation price and the variable cost of the product. This is a empirically valid formula. We can use it as a formula. If you remember my last example that we have cited in illustrating the reservation price concept, there what was the variable cost that we considered? It was $60. And what was the maximum reservation price as for that example? It was $130, right. So, $60 and $130. Then what we can do? That was not maximum reservation price, that was the reservation price by the individual who put the highest bid, right. So, if I consider the maximum reservation price as the next point of that $130, so $140 plus $60, that is 200 divided by 2, it makes the optimal price at $100. In our empirical example also we saw it that $100 was the optimum price point. So, this we can also see with some other examples as we go through this class. Next comes the gross margin at the optimal price. Generally, the gross margin on a product at its optimal price will be the negative inverse of its price elasticity. In the last class, we had a detailed discussions regarding price elasticity. What is it? It is nothing but percentage change in quantity demanded divided by percentage change in price, which is a negative value, right. So, although it can be difficult to apply, the relationship offers a powerful insight. In a constant elasticity demand function, we discussed, right, for a straight line, if the demand is visualized as a linear straight line, then at each price point the elasticity keeps changing, but the slope of the line will remain constant. But on the other hand, if the demand quantity demanded is visualized as a demand curve, then in that case at each of this price point the slope will keep changing, but the elasticity of price will remain constant. Optimal margin follows directly from the elasticity in case of elasticity demand function. This greatly simplifies the determination of the optimal price for a product of a known variable cost. So, if we know the variable cost, if we know the elasticity, then we can easily determine what should be our optimal price point. So, how to do that? Let us dive more into this concept of optimal price. We will start with understanding the purpose of this metric. Primary purpose as far as this metric of optimal price is concerned is to determine the price that yields the greatest possible contribution for the product line or for the organization. Although optimal price can be defined in a number of ways, a good starting point is that price that will generate the greatest contribution by a product after accounting for its variable cost, right. If the manager said the price too low, how can we determine? So, we have to look into the conditions. First one is that if we set a price that is too low, what happens? Then in that case, we forgo the revenue from the customers who would have otherwise willing to pay a premium than the price set. So, we are intentionally squeezing our contribution margin. In addition, a low price can lead customers to a value product less than they otherwise might. So, if you reduce the price of the product, then there is a possibility that it will give a low quality perception. As far as psychology is concerned, most of the time it goes to a longer extent, higher extent, that quality of a product is perceived as the price of the product. In some of the segments it becomes a surrogate variable. That is, it causes them to lower their reservation prices. So, once the customers start perceiving that quality of the product is not good because the price of the product is less, so now from next time onwards my reservation price for that particular product will be lower. So, it has two impacts. One is squeezing on the contribution margin, another one is giving a wrong perception of the quality. By contrast, if the manager set the price too high, they risk losing contributions from people who could have been served profitably, right. So, let us say if I have set the price at $130 as per as the examples that is concerned in illustrating the reservation price, then in that case I would have ended up just getting one customer and the profit would have been much lower. So, I would have lost the additional 3 customers which would have been profitable. So, that is why as a manager we need to make a trade-off between contribution squeeze and the demand. So, that trade-off can be determined by this concept called optimal price. Now, let us look into this equation of how to determine the optimal price for a linear demand function where we know the maximum reservation price, where we know the variable cost of the item. For linear demand, the optimal price is the midpoint between the maximum reservation price and the variable cost of the product. In linear demand function, the price that maximizes total contribution for a product is always precisely the halfway between the maximum reservation price and the variable cost to produce that product. Formula wise, it is maximum reservation price in terms of dollar plus the variable cost in terms of dollar divided by 2. So, that becomes your specific optimal price point, and if you set the price at that particular price point, then you are going to derive the maximum profit for that product. So, this is how we construct the concept of optimal price for a linear demand function. Now, we will try to combine these two metrics, that is optimal price and gross margin at the optimal price. From the previous slide, we have already understood how to calculate the optimal price for a linear demand function. Let us denote it with P star. So, P star represents the optimal price of the product. Let us also consider that if you see in the graph of on the left hand side, MRP is the x intercept of the linear demand function, that is maximum reservation price. This concept is already illustrated in our previous classes. And let us say the variable cost is the VC is the variable cost per unit. Now, the previous optimal price formula does not reveal the quantity sold at a given price or the resulting contribution. To determine this optimal contribution, now managers can use the formula that is given in the slide. So, contribution we can calculate as a ratio of MWB, that is maximum willingness to buy, or the number of people who will buy the product given that the price of the product is set at 0. So, in a way maximum willingness to buy is the overall market size where the constraint of price is not kept. So, it is MWB, maximum willingness to buy, divided by maximum reservation price multiplied by P, that is the price set, minus the variable contribution whole square. So, this is a non-linear equation. So, we will be calculating the contribution with this formula. Now, let us jump into some of the examples. Jamie's business sells goods at cost $1 to produce. Demand is linear. The price, if the price is $5, Jamie believes that he won't sell anything. So, this is the maximum reservation price, which is $5 in this context. For every dollar decrease in price, Jamie believes that he will sell one additional unit. Given that the variable cost is $1, the maximum reservation price is $5 and the demand function is considered to be linear, Jamie can anticipate that he will achieve the maximum contribution at a price which is midway between the variable cost and the maximum reservation price. So, in this context the variable price is $1 and maximum reservation price is $5. So, 1 plus 5 divided by 2, that is $3. So, as far as this context is concerned, the optimum price can be set at $3. In a linear demand function, managers do not need to know the quantity of product demanded in order to determine its optimal price. So, if you know this information, what is your MRP, what is your VC, done. Irrespective of any other additional information, you can easily calculate what should be your price set. But the bigger assumption here is that you consider that the demand is following a linear demand function, fine. So, in case of linear demand function, managers do not need to know the quantity of a product demanded in order to determine its optimal price. For those who seek to examine the Jamie's contribution figures, however, please find the details in the table below. So, you can just have a look at this one. We do not need this additional information, we can directly calculate the optimal price, but this is how the data are presented. The same can be reinforced from the formula, from this data table as well. So, at $0 If the price is 0, the maximum quantity demanded was 5. That is why then variable cost was 1 and then contribution was minus 1 and total contribution was minus 5. At $1, there is no loss, no profit, quantity demanded 4. At $2, quantity demanded is 3 and so on. So, we can see that at $3, we are maximizing the total contribution, that is $4, right. So, this empirical data that is displayed in this table reinforces the formula that we have used for calculating the optimal price when the demand is considered to be linear. Now, look at this example. Jamie develops a new but similar product. Its demand follows a linear function in which the maximum willing to buy, that is MWB, is 200, maximum market size, and the maximum reservation price is $10. Variable cost is again $1 per unit. Jamie knows that his optimal price will be midway between the MRP and the variable cost, that we already know, that is variable cost is $1 plus maximum reservation price is $10. So, it is 5.5 per unit. Using the formula for the optimal contribution, Jamie calculates the total contribution at an optimal price. So, what is the formula given for total contribution? It is MWB divided by MRP multiplied by price minus variable cost whole square. So, what is the MWB value here? It is 200. What is the MRP value here? It is 10. So, 200 divided by 10, that is 20, multiplied by what is the price, optimal price that we have calculated earlier. It is 5.5 minus 1 whole square, that is 4.5 whole square. So, it is giving us a value of $405. So, this is the maximum contribution which we are gaining at the optimal price point of $5.5. Now, the same can be verified from the given table. You can see when the price is $6, variable cost will remain constant, that is $1, quantity demanded was 80, when it is 5.5 quantity demanded was 90, when it is 5 quantity demanded was 100, when it is 4 quantity demanded was 120. See, from 6 to 5.5 the transition is about only 0.5, that is what quantity demanded increased by 10 units. From 5.5 to 5 also the transition in terms of price is only $0.5, that is what quantity demanded transition was 10 units, but in case of 5 to 4 the transition of price is $1 and that is why the transition of quantity demanded is 20 units. So, basically we can consider that it is a linear line, and that is why if we put this one and calculate the contribution per unit at each of this price point and we calculate the total contribution, we can easily see from the table that maximum contribution is derived at the price point of $5.5. It reinforces the formula that is used for calculating the contribution of the optimal price. Now, let us look at this construction of optimal price in general. Remember that linear demand function is a special case, it may not be a practical case, it is just a theoretical concept. When the demand is linear, we have an easy to use formula for the optimal price that we have already seen. Regardless of the shape of the demand function, there is a simple relationship between gross margin and elasticity at the optimal price. So, if you know the elasticity of the optimal price, we can easily calculate the gross margin at that optimal price, irrespective of any additional data, and that is given by this formula minus 1 divided by the elasticity at the optimal price. So, if you know what is the elasticity of that optimal price, then we can easily calculate the gross margin at that optimal price. The optimal price is the price at which the product's gross margin is equal to the negative of the reciprocal of its elasticity of demand. A relationship like this which holds at the optimal price is called the optimality condition. So, at that particular price point we are getting the optimal benefit. If elasticity is constant, then we can easily use the optimality condition to determine the optimal price. Remember that elasticity is considered when we follow a demand curve for calculating the quantity demanded, which is more practical than a linear demand function. We simply find the negative of the reciprocal of the constant elasticity. The result will be the optimal gross margin. If the variable costs are known and constant, then we need only determine the price that corresponds to that calculated optimal margin. So, we will look into it with examples. So, let us look into this example. The manager of a stall selling replica sporting good knows that the demand for jerseys has a constant price elasticity and which is -4. To price it optimally, she sets her gross margin equal to the negative of the reciprocal of the elasticity of demand, right. So, what will be the gross margin at optimal price? That is -1 divided by -4. So, it is 25%. So, at the optimal price point, we can visualize that, we can see that contribution margin that we are getting is 25%. If the variable cost of each jersey is 5, then we can calculate the optimal price. So, variable cost is 5, then price is unknown. So, price minus variable cost will give us the contribution margin, right. So, P minus $5. So, this is how do we calculate the contribution margin? Contribution margin is calculated as a percentage of price. So, basically P minus $5, we know what is the contribution margin, right, and that is 25%, right. P minus $5 divided by, this is the absolute contribution, P minus $5 is the absolute contribution. So, P minus $5 divided by P is 25%. From this we can calculate the value of P, which is coming as 6.67. So, you can just put it as the equation and then calculate the value of P, which will come as $6.67. So, this is our optimal price given the price elasticity at the optimal price and given the variable cost of the product. Now, let us look at another phenomenon of which is called price tailoring, which is also known as price discrimination. This is a phenomenon where we try to leverage on the consumer surpluses. When we understand that various consumers are ready to pay various prices for the same product, then in that case what we will do, instead of charging the same amount of money to all the customers, I can also look into charging various price to various customers, probably with a at least apparent value addition. Marketers have invented a variety of price discrimination tools, including coupons, rebates and discounts. All are designed to exploit the variations in price sensitivity among the customers. Somehow, if the customers are price sensitive, I will go with a extending an offer at a particular period of time. Remember that extremely price sensitive customers will always wait for a discount time frame, let us say the big billion day by Flipkart and Amazon. So, they will wait till that point of time because they are extremely price sensitive. Somebody else who is not so price sensitive, but they also seek the same product, they will not wait for the big billion day. So, this is a kind of, we are intentionally doing a price discrimination, right. So, whenever customers have different sensitivities to price or different costs to serve, the astute marketer can find an opportunity to claim incremental value through price tailoring. So, price tailoring or price discrimination is done in two ways. One is we will keep one price for all the segments, another one is that we will keep price per segment. So, for different segments we will keep different prices. So, let us dive into each of these alternative in detail by two examples. The first example is alternative A, that is one price for both the segment. Let us say we have two segments, one we are naming as value quantity and another one we are naming as style. So, one is value oriented customers, another segment is style oriented customers. So, suppose the sunglasses manufacturer plans to offer one price to both the segments. The table that is given in this slide shows the contribution of several candidate prices. The optimal single price, as you can see, is 6.77, generating a total contribution of 98.56. So, how it is tabulated is, when the price is $5, for the value segment the quantity demanded is 20, and for the style segment the quantity demanded is, let us say, 8.33. So, total demand will be 20 plus 8.33, it is 28.33, right, and total contribution will be 85.00. So, basically contribution will be, what will be the contribution per unit? It is basically average contribution per unit, it will to 85.00 divided by 28.33. For each of the segment the individual contribution per unit will be different, right. So, if it is 6, then value segment demand comes as 16, then style segment demand comes as 8, total demand 24 and 96. So, similarly, if we calculate the total contribution that we are getting at 6.77 price is 98.56, which is the highest among all the price points. So, this is the optimal price whenever we are considering the same price for all the segments. Now, another way here, what we can see, what we can conclude is that we have to sell a total of 20.67 items. Now, let us look at another scenario where we are pricing the value segment differently from the style segment. So, if the manufacturer can find a way to charge each segment its own optimal price, it will increase the total contribution. You can see in this table the optimal prices, quantities and contribution attainable if each segment pays a distinct optimal price. So, for style segment, as we know that MRP is $30 maximum reservation price, for value segment the MRP is $10. We also know that variable cost, that is $2, and that is how it is calculated here, right. The total contribution is calculated by minusing the variable cost for each of this segment multiplied by quantity demanded for that segment and summing up the contribution for both the segment, right. So, now the MRP is $30, variable cost is $20. So, now for the style segment, I know if I consider that it is a linear demand function, then in that case what is the optimal price? It is $16 and the quantity demanded is 4.67. So, what is the total contribution that I am getting? That is 65.33. And for the value segment, if I set a price at $6, which is the midway between the variable cost and the MRP, then in that case I am getting a total contribution of $64. So, overall contribution for both the segments is $129.33. I have sold the equal quantities, right. So, in one case I have sold 4.67 and to one segment and 16 units to another segment. In the previous example, I have sold 12.9 to one segment and 7.74 to another segment. So, same quantity I have sold, but by pricing them differently as per their maximum reservation price, what I am getting is I am increasing my total contribution from $98.56 to $129.33. These optimal prices were calculated as per the midpoint between the maximum reservation price and the variable cost, right, and ultimately the contribution can be calculated with the formula that we have devised earlier, that is MWB divided by MRP multiplied by optimal price minus VC, that is variable cost whole square, right. So, this way we can calculate the what is the contribution, right. So, for style segment I am calculating 65.3, and for the other segment I am calculating it as 64. So, total contribution is coming as 129.33. So, I think I can also manually calculate the overall contribution, not a problem, right. So, but what is the conclusion that I can give, that for a linear demand curve, if I mean set the price differently for different segments having different price sensitivity, having different maximum reservation price, then in that case I can derive more profit rather than setting the same price. Why this phenomenon is happening? Because if you set the same price, probably you are extending more space for the consumer surpluses. But if you are setting different prices for different segment, the scope for consumer surpluses is squeezed, and that is why the contribution for the organization is maximized. So, this is what is for today. I will expect to see you in the next class. Thank you.